Hi guys, so in this lecture we'll be discussing a new topic called hyperconjugation. So let me write the heading, hyperconjugation. So far we have discussed inductive effect, resonance effect. Now we'll discuss hyperconjugation. So before discussing or coming to the definition of hyperconjugation, let me take some examples, because this is my approach of teaching students from the beginning, that I take up more examples than theory, so that especially in organic chemistry, so that it kind of establishes a strong base into their minds, so that they can leverage that whenever they face the actual examinations. Okay, so we have some alkenes, and you have to calculate the number of alpha hydrogen in those alkenes. I'll tell you in a short while what is called alpha hydrogen and how do you actually calculate that. We have alkenes and you have to calculate number of alpha hydrogen in those alkenes. My writing is poor, so please pardon me for that. Okay, so we have alkenes such as we have, so what are the number of alpha hydrogen for this alkene? So this is the alkene group, right? So number of alpha hydrogen is just the number of hydrogens which are attached directly to the alpha carbon. So what is the alpha carbon? Alpha carbon is the first carbon adjacent to the alkene group. So the first carbon adjacent to this alkene group is this carbon. So this is the alpha carbon, and how many number of alpha hydrogens are there? So it is just the number of hydrogen attached to the alpha carbon. So in this case 2. Okay, second example is what about this case? So in this case this is the alpha carbon and there is only one hydrogen attached to alpha carbon. So this is, for this case answer would be 1. What about this case? So this is the alkene, number of alpha hydrogen on this carbon, this alpha carbon is 0, so answer is 0. So let's calculate the number of alpha hydrogen for this compound. How many number of alpha hydrogens are there? So this is the alpha carbon, this is the alpha carbon, this is the alpha carbon, this is the alpha carbon. Why? Because these are the direct attached carbon atoms to the alkene. So how many number of alpha hydrogens are there in this compound? So here is a C atom, here is a C atom, here is a C atom, here is a C atom. All the carbon atoms are having 3 hydrogen atoms. So 3 multiplied by 4, answer would be 12. So by now I think you might have known how to calculate the number of alpha hydrogens for alkene. So the definition of hyperconjugation is that hyperconjugation is defined as sigma by conjugation, sigma p conjugation, and hyperconjugation is also known as no bond resonance. More the number of alpha hydrogen in an alkene, carbocation or free radical, more is its stability. Okay, so the definition is very much clear by now, that more is the number of alpha hydrogens, more is the compound stable. So the definition is hyperconjugation is defined as sigma p conjugation we'll look into what this means in some coming minutes. So How to draw conjugating structure? So first remove the alpha hydrogen in the form of H plus from the nearest carbon atom, that is the alpha carbon, and then negative charge of alpha carbon is in conjugation with pi bond, right? So first thing is just remove alpha hydrogen in the form of H plus, and second thing is negative charge of alpha carbon is in conjugation, which we just defined here, with pi bond of alkane. Hence hyperconjugation is defined as sigma pi conjugation. Okay, so now let us take some example that you would be better able to understand it. We have something like this. So in this case, this is the alkene group. So what is the alpha carbon here? This is the alpha carbon. So just let's remove one hydrogen atom from here. So we get CH2 negative charge. Hydrogen atom is detached from this carbon atom, and we have this structure, right? So what would happen is we would convert this again into something like this, the same resonating structures which we actually saw in when we were understanding how to draw resonating structures. So in this case we have two resonating structures for this compound when we actually remove the alpha hydrogen. So number of resonating structures for this alkene group through hyperconjugation is 2. So we can actually set it as a rule of thumb that number of hyperconjugating structures in case of alkene is number of alpha hydrogen or number of alpha hydrogens plus 1. Okay, so just remember it as a rule of thumb. These type of questions are asked in many of the national level competitions like JEE. So what about hyperconjugation in cation? So let us take example into hyperconjugation in case of cations. Okay, so we have something like this structure. We have okay, so let us compare its stability with this cation. So in this cation we know that the number of alpha hydrogens are 3 into 3 9, and in this case number of alpha hydrogen are only 3. So more the number of alpha hydrogen, more are the number of resonating structures, and more is the stability of this cation. Okay, so in case of cations, number of hyperconjugating structures in case of cation are just equal to the number of alpha hydrogen, unlike in this case which was number of alpha hydrogens plus 1. So I'll again write it that number of hyperconjugating structures in case of cation is equal to number of alpha hydrogens. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing hyperconjugation in case of number of hyperconjugation conjugating structures in case of free radical, and we'll deal with some of the more examples pertaining to them. Okay, thanks for listening. Good luck and goodbye.